Okay, I think we should start right now. So thank you so much for being here. Special thanks. Allow me to introduce you first, Christian Beck and Matt Biilmann. They are from Netlify. They are going to do a presentation. They are going to talk about it, so I will let them speak about the topic itself. But thanks anyway, people from Quito, Cartagena, Medellin, and all the people that is going to be connected remotely. Thanks so much for this new Launch and Learn from Jobsity. So I will leave you with Matthias. Thank you.
Thank you. Great to meet all of you. Thanks for the invite to give this talk to you, and thanks for being here. Let me see if I can get the screen sharing going and start the actual presentation.
We see it.
Here we go. Okay, I'm Matt Biilmann from Netlify, and I'm here together with Chris, who is my co-founder. Netlify is a developer platform for building, deploying, and managing modern web projects. Both me and Chris have a background with a couple of decades of experience in building web projects in different forms. I spent a while in Spain at a company where we automized the product process to a large degree. We had an agency aimed at small to medium businesses, but building around 100 websites a week, tens of thousands of sites a year. Network of freelance designers doing the actual design work, and then in-house support team, project management team, and a sales team, and a 20+ people tech team that built the whole platform that all the designers would use to do the actual design with, all the clients would use to run the content management with, and the platform that ran every single site from brief to production site. And then based on that, I started a company called Webpop. That was a cloud hosted CMS specifically aimed for professional developers and agencies building sites for others, and just trying to give some of the same efficiencies that we had in the Spanish company to that crowd. But then what happened was that while I was working on Webpop, I started seeing some massive changes happening in the space of front-end development. When I first started Webpop, the #1 feature request I would get all the time was FTP access, and today that's not really even a thing anymore, right? Git has become a massive phenomenon, and it's not so long ago that front-end developers, the version control they tended to do was folders with names like version 4, final, very final, and so on. And today, Git has just become a standard, not just for version control, but also as the main way that developers collaborate, communicate, and even expect to publish. Microservices have exploded. At first, just for sort of the backend side of things, where we started splitting large monolithic applications into microservice systems, but also now in terms of just having an ecosystem of microservices that we can talk to straight from the browser. And in the browser world, modern JavaScript has completely changed how we think about the browser. Just some years ago, JavaScript was this little scripting language that we would add to a site to make some small interactions and stuff. And today with modern ES6, it's a full-fledged development platform, and the browser is essentially turned into an operating system. Together with that, we've had this rise of all the front-end frameworks, React.js as an example, but also Vue and Angular and Ember and so on, that has really introduced real software architecture to the client. So what we've seen is sort of this evolution of the web, where in the early pre-web days, we had this Unix model of a client talking to a server, in very, very simple client server model. Then as we started building out the web, we we invented this idea of having every website essentially be a large monolithic application where the browser as the client would talk to a web server, the web server would talk to an application server, the application server would talk to a database, would get back data, would take that data and mix it with templates, and then we would send back HTML. In many ways, it was all about working around the fact that the client was very, very limited, right? Like the browser used to essentially be a document viewer. So in order to build social web or e-commerce or anything like that, we needed to move all the weight to these large monolithic server-side applications. Now with the modern web, we're starting to see a change where the browser will load a client, like will load a JavaScript client and the markup needed to drive it directly from a content delivery network with points of presence all over the world. And then instead of having like a simple client server model, we have a client services model where the browser will talk to many different services and not just to one specific service. So that gives us this new stack with you can really talk of it as a decoupled architecture, where we started really decoupling the front end part of our architecture from the back end and microservice part of our architecture. Typically, almost all front end developers today have started working with some form of build tool. In some cases, the build tool is a static site generator that you run and it spits out a whole website with all the HTML pages. In other cases, the build tool is something like Webpack that's specialized in just building out the JavaScript bundle and the initial payload for a single page application. And in more and more cases, it's a mixture of these kind of tools. It will deliver a pre-built front end to a CDN, and the front end will live just on the CDN on points of presence all over the world instead of this idea of having like a central web server. And then you'll have a browser loaded and talk to all these different microservices. And this gives us like this plugs very naturally into this modern Git-centric workflow where developers just work in a Git repository and just have the expectation that whenever they push to Git, some system will pick up the changes, will run a continuous delivery process and push the new version to a CDN. The potential of this compared to sort of the legacy stack where we built the site every time on the fly are really huge, right? The more we can push like a pre-built front end to a CDN, the more we'll get the benefits of much better performance. The actual content will be delivered from a point of presence really close to the user. We take away so much of the security issues that we're associating with, especially systems like WordPress or Drupal or all the legacy big monolithic CMSs. Like at Netlify, to give some context, we don't allow any of these kind of server-side rendering processes, but we still get millions and millions and millions of requests every month, starting with WP admin, just from malware that's scanning our system, seeing can they find any WordPress installs and infect them. And then scalability has just also become like one of these issues that as the web has grown, the amount of traffic that's suddenly going viral on Facebook or being popular on social media can send to a website has exponentially increased year after year. And having your site just pre-built and ready on a CDN gives you an out-of-the-box way of solving that. So we've started to talk about this new stack as the jam stack, sort of saying that the stack has moved up a little, where before the stack we talked about was really like the LAMP stack, for example, right, which was like Linux, Apache, PHP, MySQL, and we were talking about like the programming language you use, the specific database you use, the operating system and the web server. Today, instead, we're talking about the runtime environment of delivering markup to a browser and then having JavaScript as a dynamic runtime environment, talking to different APIs that can either be custom built or third-party services. A way of looking at this is kind of the similarity to the architecture that we've adopted when it comes to mobile application development. So when mobile apps started to become a thing, no one thought, okay, let's make mobile apps in a way where every time the user clicks on some interaction, the phone will download a new version of the UI and show the new state of the UI. Right? It was just completely naturally that you thought about having this application that gets installed on the phone through some fairly cumbersome app store publishing process that's unique to each vendor and so on. But an app that gets installed on the phone and then talks to all these different services directly from the phone. So a normal mobile phone application will easily talk to a wider range of services like Twilio or Stripe or all kinds of different services to carry out these different interactions. And that process we're starting to see applied to the modern front-end stack as well. So we have this CI/CD process that delivers a front-end directly to a content delivery network. The browser sort of downloads the front-end from there and then talks to all these different services and APIs. Now, to make things more manageable and make the workflow around that much better for developers and much easier to reason about when it comes to staging environments, production environments, and so on, we start having this concept of also using the CDN, not just as the delivery mechanism as for the front end, but also as a gateway layer, like an API gateway or things like that, that can coordinate the routing to all these different services, and in some cases also put in place things like access control or rate limiting or signing requests. We're also starting to see this rise of serverless functions. So AWS Lambda was really the pioneer there, and now the other clouds are sort of playing a bit catch up with Google Functions and Azure Functions. But the idea of having this way of writing some code that we don't have to worry about in any sort of server-side characteristics of, we don't have to worry about where it runs, that can become really, really powerful as a way to glue together different services. When we have a set of external services and we have a front-end team, if that front-end team can just write a little glue code to tie those different services together, suddenly we'll see that small front-end teams can get really big deals done on their own. So time to go a little more back to Netlify itself and to how we are trying to build viable workflows around this stack I just described. So Netlify, as I said, is a developer platform that includes continuous integration, our own custom content delivery network, and AWS Lambda Integration, identity services, many other things. If any of you are familiar with React, you probably know Create React App. It's one of the most popular repos in GitHub. I think there's currently around at least 180,000 different GitHub projects that's based on Create React App. And it's sort of become the most popular starting point for creating new React applications. At Netlify, we have a little clone of this called Create React App Lambda. And it's called like that because it's a really easy starting point for setting up a React frontend that also includes some server-side code running in Lambda functions. Now, I'm going to start by triggering a deploy to Netlify process. Just before that, the only change from the official Create React App repository is the inclusion of this little Lambda folder where we have a hello.js. When I go here to Netlify and click Connect to GitHub, what's going to happen now is that Netlify is essentially going to do the process that it used to take a team of DevOps people probably a couple of months to get set up, and often not as smoothly. So by clicking this one button, I've gotten a new clone of the GitHub repository into my own GitHub account. And Netlify has set up a full continuous deployment process. We're seeing like the first build running now. Netlify just installed all of the dependencies. Those dependencies will get cached automatically between builds. Now we run the build process, and now Netlify has done a deploy to a production quality CDN built across 7 different cloud providers with points of presence all over the world. And if I click through here, I have a new React app running, but not just the React application. If we look at this little Lambda function here, we'll see that it's like a really typical AWS Lambda function that exposes a handler that takes an event and a callback, and then in this case just returns a little bit of JSON. And now if I go to my new deployed application and click call Lambda, we'll see that we can talk to that Lambda function under a relative path. So under .netlify-functions/hello, just based on the name of the file, anything under that path will get routed to this little function and will invoke the Lambda without me having to set up any API gateway integration or anything like that. And now this is tied in really deeply to a Git-based workflow. So if I click through here and go to the new repository that Netlify created for me, I can go in, I can take this Lambda, and I can make an edit and say, hello, Jobsity here. Let's turn this into a little pull request. So I'm creating a new branch now and creating a pull request. And just by doing this immediately, we see like a new deploy preview is processing. So this means Netlify has picked up this pull request and is starting to run a new build. And for this build, we'll see the dependencies are already up to date. They've already been installed, so it'll be much faster than the initial build. We run this, we build out the functions, and now the deploy is live. So if I click through here, I'll see that I have a new URL starting with deploy preview 1, and then the URL of my site. And if I click the call Lambda button here, I get hello Jobsity. If I go back to my master version and click it, I still get hello world, right? So that means that just by doing that instant 30-second setup, I've essentially created like a continuous deployment flow to both Netlify's global CDN and AWS Lambda, where every single pull request turns into a staging environment without me having to do anything. We can go in through our build settings, for example, and easily set things like environment variables that will be available to our Lambda functions. So this is how you can build very advanced functionality with just a little bit of glue code. One example of working with this kind of stack that we've done a bit of case studies around, and that you can expect to see more in-depth technical material around in time is Smashing Magazine's migration. So Smashing Magazine is a front-end publication. It's one of it's probably the most popular online publication for front-end designers and front-end developers. They made a huge transition from a stack that used to consist of WordPress, Shopify, a Ruby on Rails app, and a PHP CMS called Kirby, onto just a statically built out front end. So when I click around on any of these pages on Smashing Magazine, everything has been pre-built and is living directly off a CDN. There's no server side involved at all. But if I go to some section, for example, like the membership, and I go to my plan setting, and I go to change a plan, I get like a client-side UI for doing these upgrades and so on. If I go in here and I fill in a credit card number and a cardholder name, and I click become smashing, this site will fetch do the Stripe flow of getting a token representing this credit card from Stripe, and then we'll send that to .netlify/function/membership. And that's a little Lambda function that will take that Stripe token, create a subscription in Stripe, update the identity of the user, and then return. And that means that we suddenly have like a whole subscription service built in just a few lines of server-side JavaScript. I won't go like deep in details with the whole project, right? But one thing that was just really fascinating was to see that this whole project that includes like events with ticket checkout, it includes a full e-commerce selling both printed books and ebooks. It has membership with like a gated content that you can only see based on the membership status you have. It has a job board, and obviously like a really active magazine with thousands and thousands of articles and more than 200,000 comments. This whole project was built by a small team of just front-end developers, no actual back-end developers. And then a set of reusable microservices, like the identity service used for handling membership, like Stripe, like MailChimp, like GoCommerce, a small microservice for handling e-commerce, and then 575 lines of server-side JavaScript in 3 different Lambda functions. And that was all the custom server-side JavaScript. And that meant that this whole project could be built from end to finish by just a front-end development team without an actual back-end team behind it. Let's go back to the presentation. So Netlify itself, which I just showed, what it consists of is a custom content delivery network, a full automation platform, and then our layer of like a microservice gateway combined with add-ons. So one of the really early decisions we had to make when we set out to build Netlify was building out our own custom CDN from the ground up. And this was like a big deal. We started up, Chris and I, bootstrapping Netlify, launched the first version out of private beta in March 2015. And initially we were definitively thinking there has to be a way around this. We're not going to build our own content delivery network. But we realized when we really started mapping out the space and mapping out like what's Netlify's role, we saw this new decoupled category, this Jamstack approach to building sites. But what we could see was that while the potential of the category, while this way of decoupling the front end and the back end had so many potential benefits, the workflow around it was just not really there. And one of the things we realized that we needed to build to actually be able to make that workflow really, really click was a custom CDN that can really replace the role of the web server. Fortunately for us, like 5-10 years ago, if we had wanted to build a custom CDN, agreements and with data centers all over the world, we needed to ship hardware to data centers all over the world, and we would have needed like massive capital backing. It would have been a completely different process. Fortunately, today, for the kind of CDN we're building that's focused on replacing the web server and serving the front end files, which are typically small rather than focusing on traditional CDN roles like streaming large video files. Building a CDN that way today would actually have been a really stupid approach, because we no matter the backing we had gotten, we would not have been able to get better peering agreements and network agreements than AWS or Google Compute or any of the really big players. So what we did instead was building a multi-cloud CDN. And today we operate points of presence across AWS, Google Compute, DigitalOcean, Host Virtual, Azure, Rackspace, and Alibaba. And that gives us a really broad network with very good coverage, and where we can cherry pick from each of these different providers in the different regions, which of them actually have the best peering agreements and the best networking conditions. One of the things that it allows us to tackle instantly was the idea of atomic deploys and instant cache invalidation. So if you imagine a site like Smashing Magazine with tens of thousands of HTML pages, and you add a new category, that will be one of the deploys that triggers like basically all of those tens of thousands of pages changing, because it needs a new category link. If you just naively upload that site to S3 or something like that, then whenever a change like that happens, the whole site will be in an inconsistent state for as long as the deploy is ongoing. You might not actually have uploaded the category detailed page while all the pages referencing the category is getting uploaded, and users might get like a really bad experience with broken links and so on. That's fine if the project is your personal developer blog or a prototype. But if it's like a real commercial property, that's just a deal breaker out of the gate. It's not acceptable. The same goes from instant cache invalidation, which has traditionally been really tricky to get right with content delivery networks. You need to have this trust that on the one hand, the actual HTML files should be delivered straight from the CDN edge nodes, right? Like there shouldn't be a round trip to an origin on every request. But at the same time, you also need this guarantee that when a change goes live, it goes live instantly. And the moment the new atomic deploy is ready, every CDN node around the world picks this up and starts serving the new version. So that's something we had to solve. Then owning that software layer also allows us to tackle some of the things that you would traditionally use a server from. One of these things are things like GeoIP-based rewrite rules or proxy rules, all the complex logic. Other things are things like split testing. So for Netlify, if I go into a site and I activate branch deploys, then Netlify will start building not just your main site and your pull request, but also any branches that you pick. And then I can start doing things like saying, okay, for this site, start splitting the traffic. So I serve like 50% for my master branch and 50% from my UI redesign branch. And that will happen directly at the CDN edge level, which means there'll be absolutely no performance loss. Something that's traditionally really been challenging for running A/B tests, especially once you give up running your own web server. So all of these things were things that building our own multi-cloud custom CDN started enabling. Then we have this deep automation layer that I just showed, and it really comes from this idea that that infrastructure should just be driven from Git, right? So we have this fundamental idea that developers have a workflow around Git. We have a workflow around how we do pull requests and how we do branches and how we collaborate around that. And all the automation needed to drive our infrastructure should just start there. It's another thing that allows a bunch of new opportunities. So if we look at Smashing Magazines, obviously one of the things that Smashing Magazine had to solve off the bat for a magazine is how do we do in this process where we pre-built the whole site, we've thrown away WordPress and we're using a static site generator now. All the content for Smashing Magazine lives in the Git repository. So if I go in and navigate here and look at the content of Smashing Magazine, I can go in and I can find every single article and see that every article is like this kind of structured file with front matter and then markdown. And Hugo is going to take those and build them out. All of this just plays into this kind of Git-centric workflow. The same goes for things like Smashing Magazine's rewrite and redirect rules and so on. But what happens when you need non-technical people to collaborate in that workflow? Well, if I go to smashingmagazine.admin/admin, I'll see this CMS UI. This is actually based on an open source project that we're running from Netlify called Netlify CMS. Netlify CMS as such is not it's not tied to Netlify's platform. It's unopinionated about what kind of platform you need, but it relies on this kind of automation layer that Netlify delivers out of the box. So to use Netlify CMS, you need some kind of continuous deployment flow, and preferably one that will build every single pull request you manage. The way it works is that it sits on top of GitHub. So it just becomes a visual UI for managing content that lives as structured data in GitHub. The CMS is a single page app built in React. So when I go in here and start editing articles for Smashing Magazine, and I'll make sure not to save since this is their production setup, everything happens client side. I'll see like live preview of any changes I make. I can get an idea of how will this look like once I hit publish. And it's like a very natural content editing experience. But behind the scenes, everything a content editor does here maps onto an operation in GitHub. So if I go into GitHub and I look at the pull request to Smashing Magazine, I'll see things like this article being created by the CMS bot, where Jana has done a bunch of commits and created a new markdown file. Just by doing that, again, since we have this whole automation flow, I can see that Netlify has picked this up and we've built a new version of the site, and we've notified Jana in Slack that she can preview the article here. And in the CMS, we've set up like an editorial workflow that says, okay, this article is a draft, which means it's essentially a pull request. If I dragged it over to ready and I click publish, then the CMS would merge in that pull request. And again, Netlify's automation layer would simply pick that up, run a build, and deploy the new master version. And that's just kind of some of these things that become possible once you just have this deeply integrated routing and CI/CD layer that really ties into how developers are already working in Git, and make sure that the whole process around it gets automated without anybody needing to play an operations role. And then the last layer is this microservice gateway layer and add-on layer that we can run again because we have this tight integration between this automation flow and the CDN edge network, where we have some services like our integrated identity service. So when I go to Smashing Magazine and I sign into this content management system, or when I just go and adjust my membership on my profile. That's the whole login, logout, sign up flow is based on an open source service called Go True. A small microservice written in Go that we've made available to the ecosystem. And as part of Netlify, we run this Netlify identity service that can be enabled with a click for any site, and that gives you this kind of API for managing signups, forgot my password, logins, and everything, and has the concept of JSON Web Tokens. JSON Web Tokens is essentially an approach to how to get around the fact that when we have all these different microservices that don't know about each other, how do we allow them to still know about the identity of the user that's talking to them at any given point? And JSON Web Tokens is a way to represent a user as a token that we can pass around to these different services, and then each service can use a cryptographic signature to verify that the user, that the identity we're passing to them is indeed that of an actual existing user that's been issued by our identity service. We have this AWS Lambda integration that is one of our first integrations. It really answered the question that we saw. What happens when you have all of these different microservices and you just need a little bit of glue code tying them together? Like one of the examples I gave earlier was this subscription flow with Stripe. So Stripe, obviously, like anybody today that started building their own payment gateway or something like that, that would just be crazy when you have services like Stripe available on the market that's done such a good job of that, and that's so focused on that. And they have a great subscription engine in there with lots of flexibility. But the problem is that as soon as you want to create a subscription for a user in Stripe, you need somewhere where you have a Stripe API secret, and you can communicate to Stripe in a secure way. And doing that little API request to Stripe, it's often something like 5 lines of code, but you need that code to live somewhere. So the promise to front-end developers of being able to just write that code and get it online without having to suddenly build a whole server-side applications and run it on a server somewhere, that's awesome. But what we found initially was that however large the promise was, when front-end developers actually started going into the AWS console and had to figure out, okay, so for every one of these functions, we have to set up a CloudFront distribution and an API gateway. And now I have to figure out like what version of the function should I talk to from the different versions of my app? How do I manage staging and development, especially with a set of different cloud functions? It quickly became really unwieldy and not really viable to work with. So we built this AWS Lambda integration that I showed in the demo earlier to solve this issue and say, like, we can take away all the hassle of setting up AWS credentials and all of that, and just let developers focus on writing the code, adding it in a folder in the repository, and we'll deploy it to our AWS account. Or if we have a large enterprise client, we'll deploy it to their AWS account, but we'll take all of the hassle away from the developer of doing that. And same thing around handling like routing to different APIs and so on. We can do that at the CDN level. We can do, we have rewrite rules that can be used to enforce that a user is signed in with a JSON Web Token that gives them a specific rule in order to be able to talk to different services. And we can do all of that from the CDN level at this gateway level, just giving people like a really solid platform where developers can write code in Git, and everything on the infrastructure level happens from there. And it leads us to the last part, which is really like the main reason that Chris and I started building out Netlify in the beginning. And that's just like the whole workflow around it. So when when Chris and I started making the plans for Netlify, we had this insight around like this kind of decoupled architecture, a static front end that talks to dynamic microservices. It's gonna have so many benefits. It's gonna be the right way to build the web, and the vast majority of web projects should be built in that way. But at the same time, when we sort of started dogfooding it and thinking about using it in relation to our clients, we could just see that there wasn't a viable workflow around it. You had to stitch together all these different tools. You had to set up continuous deployment for every project, figure out a way to integrate with an object store, get a CDN provisioned. There was just no great way to test all the different CDN rewrite rules, apart from like really complex Terraform setups with different environments. Pre-rendering is some things that you might want to allow if you're doing some of the work client side, but also need crawlers and bots to be able to index it. And setting that up requires yet another service, and just became this whole conglomerate of different services with no inherent workflow to tie them together. And that's what we saw, that by building out this whole infrastructure layer of our own custom CDN, our own continuous delivery pipeline, our own set of services, and more importantly, a set of provisioning mechanisms for other services, we could build this very powerful glue layer that's heavy on the infrastructure side, but that's built entirely to make the workflow for front-end developers so much easier, and to take the burden away from them of having to worry about the infrastructure setup and provisioning and management and operations. And that's what we've built, and what we are aiming today to build. Today we have around a 250,000 developers using our platform. We've been fortunate that this has been adopted massively in the open source community. So projects like React, Vue, Ember, Docker, Kubernetes, Envoy Proxy, Gatsby, the Cloud Native Foundation, and so many more are all using Netlify for their front ends. And we're seeing like the power that we can give to small front-end teams to build larger and larger projects on their own, by taking advantage of this workflow. So the result of taking advantage of that, like I mentioned that earlier in the talk, obviously, like once you give up having like an origin server and you can distribute the front end across the world, the time to first byte is going to get many times higher. In the Smashing Magazine case study, we saw around 6 times a performance increase in terms of time to first byte. Global performance is very different when you have edge nodes serving the content directly in the different countries. And the multi-cloud infrastructure we've been building out, it gives a ton of advantages in terms of reliability, uptime, and resilience. Security, again, that was one of the things I talked about earlier. Just a few weeks ago, Drupal announced for the second time that there was a massive zero-day exploit that had been picked out by scripts in the wild, and that everybody that hadn't updated their Drupal install within 7 hours should consider their server hacked. As soon as you decouple the runtime, the build process from the actual hosting, you take away like the vast majority of security exploits by serving just a static front end. And of course, you still have the dynamic microservices, and you still have to be really aware of security there, but they have a way smaller surface area, and it's way easier to reason about each service in isolation. And as services get smaller, they get more reusable, which means we get more third-party providers that we can use for specific parts of the stack. Also, in terms of like what we've built with Netlify, every single deploy is immutable. We can do instant rollbacks, from one deploy to the other at any time, which also just means that if something has gone wrong or a bad version has gone live, fixing it is like one click of the button and you're back to a known state. So that's Netlify, and our hope is that you'll all start considering running your web-facing properties without running a web server. That was my part of the talk. I'm sure there's a ton of questions, so I'll change from this and to a general Q&A part.
Hi, this is Mauricio from Jobsity. If someone remote has any questions, please proceed. I have a couple, but I will let the rest like to talk or to ask first.
Thank you, Bert.
Thank you, Anne. Thank you. It was great.
Thank you. Thank you.
No questions?
I have one question.
Come.
Okay. Hi, this is Andres. In terms of content, let's say that you run a site that has a lot of content, like a media publisher or something, and you have two processes, right? Like staging and live. Like how would you manage the complexity of content creation if you have like 20 editors at the same time, and then you have to do a rollback? Usually you have a database that it's backed up by functionality and vice versa. But if you have like 20 editors inputting content and you have to do a rollback in the functionality only, how do you manage that?
I mean, it's a big question because there are many approaches also to content, right? Like I showed how Smashing Magazine is doing it with Netlify CMS. With that approach, the advantage is that everything is in Git, right? So you have, as a developer, you have all the normal tools around Git available to you, right? And rather than having like one staging environment and one production environment, every single piece of content gets its own pull request and its own staging environment, and every piece of individual functionality that you work on as a developer typically gets its own branch, its own staging environment, and so on, right? Then there are other approaches to content editing, especially around headless API-driven CMSs. So in general, for this new stack, content editing is moving to the idea of a headless CMS, and there's a couple of different categories of those. The two main ones being like API-powered headless CMSs and Git-powered headless CMSs like Netlify CMS. So with Git-based headless CMSs, the answer is really like that you get all the same flexibility as you just do in general when you work with Git, right? Like you get all the same tools that you're used to as a developer, of pull requests, of being able to do cherry picks of specific commits and all of that. With API-driven CMSs, it's a little closer to the existing version of how you would handle those situations in something like WordPress, except that you typically still have a very easy way to move between different branches of your functionality and different versions and one version of your content, right? So a really common flow will be that you make a new pull request for the functionality, and Netlify will rebuild your site, fetching like the latest content from your headless CMS. And in the pull request for the functionality, you can see like, are the two things working together? And again, you get that kind of flow where you go from having like one staging environment and one production environment and just saying like every new thing you work for gets its own pull request that becomes its own staging environment. So I hope that answers some of the question.
Yeah, no, it does. Thank you. No, it's
awesome.
Hi, Victor from Jobsity. Quick question. Does Netlify support using custom Git servers, or is it only for GitHub?
So we out of the box, we support GitHub, GitLab, and Bitbucket. With our CLI tool, you can set up continuous deployment from any Git service that allows us that allows you to give us access via SSH with a deploy key, and that allows you to send webhooks when something changes. If it's not based on something like GitHub Enterprise or GitLab, you might not be able to get the pull request integration to work, just because that's obviously pretty unique to those platforms. But Netlify can work with self-hosted Git repositories as well.
Thanks. I have a question. Basically, you are like making easy to upload the Lambdas, right? You just show us an example.
Yeah.
The code was on the repo and the Lambda was created.
Yeah.
I have a couple of questions. How do you manage routing to the Lambda
Yeah.
that was created? Yeah. Imagine that we have like 10 Lambdas.
Yeah.
My next, and the other question that I have is, imagine that the Lambda has some computational like time, you know?
Yeah.
And you want to control cache on that Lambda. Is the Lambda behind your CDN and you can communicate with the CDN in some way? Can you explain us?
Yeah, absolutely. So in terms of the routing, one of the things that's powerful in our case is that we run the actual CDN software, right? So we can handle the routing directly in our CDN nodes, and that's one of the powerful parts of the Lambda integration. That it's based on the name of each file that's a Lambda. So in the example I showed you, I had a little file called hello.js. And that means that we'll automatically set up a relative path on your site called .netlify/functions/hello. And everything under that path, like if you append like /hello/Matt, everything under that will get sent to that Lambda function, and that Lambda function can handle it. If you created another file that called memberships, then .netlify/function/membership would route to that file. And that's also part of the power of it, is that since these are relative paths, that's also what allows us to do a deploy preview where we have a different version of the Lambda, but on the same relative path, and it just works, right? And the front end doesn't have to keep track of like, now I'm in development mode, so I should talk to this absolute URL, or now I'm in production mode, so I should talk to this one, right? All of that can just be handled through this idea of relative paths. And you can even use our Netlify TOML setup to set different environment variable depending on which context you're running in. So you can say like, if you're in a deploy preview, which is like the build of a pull request, then set a specific environment variable. And if you're in the production context, then set a different one. And the Lambdas will pick those up. And the Lambdas run right behind, like sit behind our CDN edge nodes. So I should say that right now, the one thing we don't have a great story about yet is cache invalidation if you return caching headers from a Lambda. But you can return like cache headers from a Lambda to tell our cache nodes, like this response should have a max age of 10 minutes. And then our CDN edge nodes will cache that and keep it for the next 10 minutes. At some future, I imagine that will allow some integration with our general cache purging infrastructure to make that play well with Lambdas as well. But right now we just have like in anything that you can express in terms of HTTP headers for caching, the CDN will understand and respond to.
Okay, awesome. Any more questions, guys?
I have one more question. I don't know if, well, let me go quick. Let's say that you want some functionality around the content. Again, this is based on my experience with content, which is a pain sometimes. That let's say that you have content from a magazine, a video, for example, that you can show off in Windows. So let's say you have to show this weekend, and then you don't have access the next during the week, and then you have to access again the next weekend. So usually in other CMSs, you will program in the backend to get access to that piece of content in a way that you will put some rules around that content, right? Around the content type in general. So then the rules will be in general to a content type, but then it will be specifically set up for the piece of content on the dates. How would you manage that based on your model that you have? You control your own like backend or editorial experience.
Yeah, it depends a bit, right? Like because typically this is something where there's 3 different pieces involved. There's the tool you manage, like the tool you use to manage the content itself. And then there's the tool you use to actually build out the website, like the static site generator or the build tool you use. And then for this to really work, you'll also want to think about some kind of scheduling functionality, right? So a really simple version of this, for example, is just writing a new article and saying this article should go live at this time, which is sort of similar, right? Like in terms of the content management system, you'll just want to make sure that there's like a date field that's managed as part of the article. In terms of the build tool, you'll want to make sure that there's an option in the build tool to say when it's a production build, then only output articles and only include articles and listings where that date field is in the future. And then what you'll do as the last piece of that is typically to set up like a scheduled build every day. We have that, for example, if any of you go to either staticgen.com or headlesscms.org, those are some of the resources we've built to find, like, to get an overview over all the static site generators in the space and all the headless CMSs in the space. And there we have an external scheduler set up. In this case, I think we use Zapier to trigger a webhook. Like we call them build hooks in Netlify, and you can set up a build hook where doing a post request to that build hook will trigger a new build. So Zapier, for each of those sites, every day it will trigger a new build. The build tool will run. It will, in that case, it will look at the different projects and then will fetch the latest data for the stars and issues and forks of each of them, and then update the daily project stats and the history for each project. That's a little similar. You could easily imagine having like a daily process running, looking at some settings for a content type and saying, okay, these kind of content we want to disable or we want to enable.
Okay. Thank you.
Thank you, Chris. Any more questions, guys?
I got one more. So what kind of learning resources do you guys offer to use this workflow? Like, for example, I love the idea, but I have kind of a difficult time picturing how to, for example, connect to a database. Like some database, but I don't see any straightforward way of doing it.
Yeah. And so one of the interesting things in general, just as this way of thinking changes, right, is that traditionally we've as web developers we've been very used to think of our database as this is the database and there's like one big one of them. And now when we move more towards these microservices, it's more of a setup where each of these services have their own data source, and some of those might use a database. Some of them might just run during build time and use the Git repository itself. Some might use the actual website as the source of truth, and some might have their own databases. we don't at this point go into the flow of like, where do you run your databases? That's typically related to where you host the individual microservices, and will typically be specific to those providers. But I think one of the interesting points is that if you really adopt a microservice architecture, you'll go from the idea of having one database and to the idea of different services having different data sources.
Great. Chris, can I abuse of your time? 5 more minutes?
Yeah, let me send one mail to let the next meeting know that I'll be just 5 minutes late.
That's a tight schedule, man.
But yeah, I'm happy to keep answering for a little more.
Thank you so much, Chris. I just have a final question. Thanks so much for all this talk and responding on all our questions. Which kinds of technologies do you use behind the scenes? I suppose that the front end is something like React, but what about back end? Which programming languages are you using? If you can talk about it a little bit, it would be great.
Absolutely. So on the backend side of Netlify, it's a big system, right? So the actual CDN that we run, that's C++, right? Like that's all about performance. So we're based off an open source proxy cache called Apache Traffic Server, and have our own C++ based plugins for handling all of the atomic deploys, the SSL lazy loading, the GeoIP based rules, and all of this stuff. Then all of sort of our infrastructure layer, the proxying, the connection from the CDN to origin servers, our continuous integration platform, all of that is based in Go. And all of our managed microservices, like our identity service, our Git gateway, and so on, those are based in Go. We make heavy use of Kubernetes for both the continuous deployment environment and for the managed microservices. And then we have like a traditional REST API for managing users, sites, teams, all of that. And that's a Ruby on Rails API. And yes, then all of our front end is currently written in React. And Netlify CMS is a pure single page app in React. Netlify CMS doesn't have any backend, it's just a front end application.
Great, amazing, Christian. Thank you so much for these extra minutes. Thanks so much for the talk, and see you soon. Thank you so much.
Thank you.
Thank you.
Thank you.
Awesome. Thank you.
Thanks.